Hi, today I want to talk to you about the properties of acids and bases. We all know that strong acids can burn things. Acids takes a bad rap. People think when they hear acid, it's something very dangerous. Well, strong acids are, especially concentrated strong acids. Strong bases, however, are also very, very dangerous. Those are things like oven cleaners and lye. So what we're going to talk about now are the properties of acids and bases. Let's start with one you're familiar with, hydrochloric acid. We used hydrochloric acid in several of our labs so far this year. This is not very concentrated. It's only about 1 molar hydrochloric acid. If I wanted to determine if a substance was an acid or a base, the easiest thing for me to do would be to check it with litmus paper. Litmus paper is available in these little vials. All it is a piece of paper that's dyed with a chemical that comes from lichens. This chemical is an indicator. It changes color based on the pH. They call litmus paper red litmus paper and blue litmus paper, but when I look at it, I kind of think it looks like pink and purple. But if I put my red litmus paper and my blue litmus paper into hydrochloric acid, I'll notice that the red litmus paper just gets wet. It doesn't change. The blue litmus paper, however, when I put it into the hydrochloric acid, turns red. Blue to red, acid. Blue to red, acid. Let's look at a strong base. I have here ammonia. When I put the blue litmus paper into ammonia, it's just wet. It stayed blue. When I put the red litmus paper into the ammonia, it turned blue. So blue is for bases, red is for acid. I always like to use the little rhyme, blue to red, acid, to remind me that blue litmus paper turns red for acids. And then I just remember basic blue to explain what happens with the bases. The word acid comes from the Latin word for sour. Acids taste sour. So when I look at things like that I would associate with the sour taste, like lemon juice, if I try my litmus paper test with lemon juice, I dip in both litmus papers. The red stayed red and the blue turned red. Blue to red, acid. This was a double piece of litmus paper. If I look at vinegar, vinegar also has a very sour taste. The red one just gets wet. The blue one turns red. Blue to red, acid. Vinegar is acid. So a lot of these things that we think of with sour tastes are acids. What about the taste of bases? You guys have all used baking powder cooking? I'm going to taste a little bit, and it is gross. It is bitter. Bases taste bitter. So if I put a little distilled water in here and mix it up to make a solution, I think I'm going to add a little more water. This is pretty thick. I'll see. Does my blue turn red? No, it stayed blue. Basic blue. But my red litmus paper, when I dip that in, turns blue. Basic blue. So baking powder is a base, and it tastes bitter. Back when I was young, sometimes if a kid said a naughty word, a grandma or a mom might wash their mouths out with soap because soap tasted bitter, it tasted bad. Here I have some dish soap. Let's see if bitter tasting soap is an acid or a base. The blue stayed blue, the red turned blue. Soap is a base. Acids taste sour, bases taste bitter. Bases also feel slippery, like soap. So a property of bases is that they often feel slippery. Now, let's look at distilled water again. Distilled water we know is neutral. It has a pH of 7. It is neither an acid or a base. So let's put a little distilled water in here and see how the litmus paper acts with that. The blue litmus paper stays blue. It just gets wet. The red litmus paper stays red. It just gets wet. So neutral substances, like distilled water, don't change litmus paper at all. Another thing I want to look at is electrical conductivity. So what I've done is I've hooked up a battery with some leads and a light bulb. And when I connect the two wires, you can see the light bulb lights up. Now if I put something that I knew was a conductor, like this spoon, and I connected them, it would light up. If I take my distilled water and put the two leads in, it doesn't light up because distilled water does not conduct electricity. What about acids and bases? I still have my hydrochloric acid here. Let's see if this will light up the light bulb. It's not quite as bright as with the spoon, but it does light up. It conducts electricity. Now let's see if ammonia conducts electricity. I had to straighten out a lead, but yes, ammonia will also conduct electricity. Not as good as the wires without going through it, but it's still a pretty good conductor. The other thing that I want to talk to you about with hydrochloric acid is that acids react with metals to release hydrogen gas. So I've got my 1 molar hydrochloric acid and a little piece of magnesium ribbon here, and I'm going to put the magnesium ribbon into the acid, and you can see that it starts to fizz. That's the hydrogen gas being released. In this reaction, magnesium chloride is formed and hydrogen gas is released. There's one other thing I want to talk about in relation to acids and bases. Here's our baking powder and water, which is our base. And if we add an acid, vinegar, to it, we have a reaction. Acids and bases react together to form water and a salt. It's a neutralization reaction. Here's the example of one that we do if we were in class. Hydrochloric acid and sodium hydroxide to form water and sodium chloride. Sodium chloride you'll recognize as table salt. Neither the water nor the sodium chloride have either acid or base properties. They're both neutral substances. So you can neutralize an acid, get rid of its acidic properties by combining it with a base. And you can neutralize a base by combining it with an acid. So that's it. Those are the properties of acids and bases. Acids are corrosive. They turn litmus paper red. They taste sour. They conduct electricity. They react with metals to release hydrogen gas. And they react with a base to form water and a salt. Bases are also corrosive. They turn litmus paper blue. They taste bitter. They conduct electricity. They feel slippery. They react with acids to form water and a salt.